This is a toy car. Toy car first appeared in Europe and in the United States in the early 1930s. The early models were printed in zinc press, which would make toys go corrosive, causing them to distort, crack, or crumble. In 1947, Matchbox introduced pocket-sized toys that were affordable and sold in Matchbox-style packaging, making them widely accessible and easy to produce. Now, it is mainly used to entertain kids who will one day learn and know about cars. Let's see how it is made. There are five parts: body, interior, tires, axle, and door tension. The body is the main attraction of the toy car. It is first formed in high pressure die casting. This forms the shape of the car from the real life counterpart. This huge part is made out of either zinc alloy or aluminum alloy. Using this material makes the toy car excellent for fluidity to form the body and stability. For the interior and wheel, however, the process is called injection molding, using ABS plastic as a main material. This method creates all internal structures like seats, dashboards, and mounting points in a single piece, which is easier to produce. This fundamental design choice makes it easier and simple to build and use metal as a source of weight and durability, making the toy car feel realistic like its real life counterpart. Tires are made from synthetic rubber, like the interior and wheels. It is made from injection molding. When the material is injected, it moves to the pressure to press a tire shape. Then it is cooled. After it is cooled, it is fitted to the plastic rim to make sure both parts fit together. This component is an option to some toys because it uses extra material and costs more, but it does make the toy car look realistic compared to its real life counterparts. Another optional part it is also option for toy cars and other toys is axles. This is one of the complicated parts for a toy car and toys in general because it requires multiple gears and more materials used for this part. This part is made from injection molding. After it is injected and shaped from the axle, this part is snapped and screwed to shut the other components inside, making it secure and attached to the main chassis. Similar to tires, this part is used to make it look and feel realistic to real life cars. Door tension is a part that keeps the toy car's door closed. It is mostly located behind the dashboard. It is made from spring steel and formed through CNC wire bending, a process dedicated to create a small component, ensuring that every time a child interacts with the toy car's door, trunk, or hood, regardless of whether this part is bent or snipped, the spring will return to its shape. During this project, I have faced two things: disassembly and identification for the process. Toys are engineered to be sturdy and hard for kids to disassemble. The metal body and plastic chassis were joined by heat stacking or crimp rivets. Disassembling these requires more destructive methods. For the paint, determining if it was a liquid enamel or a powder coating requires deeper research. Fortunately, I found that the paint can be easily removed. This tells me that this is painted in liquid enamel. This ensures that the paint will last forever without flaking. One of the insights that I gained from this project is that mass production is driven by material and process selection. Example, the use of TPE for the tires instead of pure rubber as an engineering compromise, the sacrifice of tiny bit of material performance for a massive gain in manufacturing speed and cost reduction. Because TPE is injection molded unlike traditional rubber. For summary, this project moves far beyond just clarifying product. We're breaking down common toy into a manufacturing DNA, forming process, high pressure die casting, materials such as Zamac, ABS, or spring steel, and finishing in powder coating and temple printing. Thank you for listening to me, discovering the process and how each part is made, assembled, and how each process helps one another to form a perfect object. This project demonstrates that principles of manufacturing process designs are everywhere, even if it's a small product on your desk. Thank you for listening.